So my session is called Sneaky PDF. Thanks for your time. So a little bit about myself. My name is Mahmoud Rahman, or Yamu, from MyShirt, part of Cybersecurity Malaysia. Interested in malicious PDF as well as Android malware reversing. So the agenda for today, I'm going to cover a little bit about intro, and then a little bit about obfuscation technique that we found in the wild that been used, and of course a little bit about challenge and issues, and the last one is about conclusion. All right, introduction. So this is not about PDF video application 0-day, so don't get confused with that. And of course, it's also not about Adobe XReader sandbox bypass. Okay, so this is plainly we're talking about PDF obfuscation, which is pretty much the same image, right? Camouflage or obfuscation, you can put whatever you want, right? So basically, when you talk about obfuscation, so you have a PDF plus obfuscation, what pretty much you expect to become? Transformer, maybe? Not really, right? Of course, you expect to become a PDF as well, right? So the topic for today is about you have a normal PDF or you have a PDF that we exploit, and then you want to obfuscate it. The main reason of why you want to obfuscate it, well, obviously, there are many reasons for that. Malicious PDF mainly come with two components. The first one is probably the exploit, and the second one is the payload itself, or shellcode rather. And then, well, the main reason, like I mentioned, is need to be off the radar. How? Obviously, you need to look like a normal PDF. You cannot expect to look like a malform, because if you trigger that, then you somehow raise a red flag for any security product for detection. Of course, what do you want to obfuscate is depend on what kind of level that you want to go. Normally, people just obfuscate on the exploit, or people want to obfuscate on the shellcode. But the two most these main components will need to be obfuscated, right? Well, why are you obfuscating this one? Obviously, you want to stay stealth, reducing for being detected. And one of the things is try to make analysis harder. Because eventually, if you were here for the previous presentation about APT, there is always, we still believe somehow in the end of the day, your tool is going to be detected, right? But you can make it analysis become more harder by implementing some obfuscation. So statistic of obfuscated malicious PDF, I don't think statistic we somehow look at this way is always going up, because that is pretty much a trend. So, yeah. And then the PDF in general, so I hope the PDF is serious enough nowadays. So this is pretty much the PDF. I tried to cover a little bit about the structures or the concept of PDF. Okay. The first one is you see on the green color box, you're going to have PDF version. And on the PDF version, normally you have something like percent something, and then you have PDF and then version numbers. One of the components that can be used to fool a couple of PDF analyzer tools is by play around with the version numbers. So not version numbers, by the header or PDF. Like for example, if you are looking like percent and PDF -1 and what kind of version is it? You need to be remembered though, because for the PDF specification, it said within 1024 byte. For the first 1024 byte, it's legitimate for you to declare the PDF version. For example, you have some weird numbers, like you can have %, or you have ABC, or whatever you want, and then you put %PDF 1.1. It still can be considered as a PDF, still can be considered as a legitimate PDF version. And then the second body for this one, if you can see over here, it's pretty much the main component of PDF, which is normally have object, normally been representing as a OBJ. and it needs to be AND with AND OBJ. Later on, I will show some rather obfuscation that you can implement when it comes to the object declaration, like this one. And then, of course, it's also part of the major component inside here is the JavaScript. And you have on the yellow box, you have over here is the cross-reference, which is somehow define the offset of each object. Okay? And then the last one, you have trailer. Trailer is pretty much the main component that have one major component called /root. /root especially give you some clue or some entry point where your PDF will start when you open the PDF. Okay? And the last one is also interesting. You have N of 5, which is representing of N of 5 for the PDF. It declared a percent N of 5, but it also can be, you can also have multiple N of 5. I will show you a demo later on this specific topic. So obfuscation. Well, commonly observed in the while obfuscation method, pretty much like I mentioned earlier, you have JavaScript, and you have a PDF syntax, and of course you have a PDF features, and the last one is probably you have media rich on PDF. Okay, the first one, abusing the JavaScript to make your PDF undetectable or make your PDF become more difficult to analyze is the sky's the limit. Whatever can be executed by JavaScript is pretty much can be rendered as well within the PDF engine. And majority of PDF reader application have a JavaScript engine. You name it, like Adobe have it, Nitro have it. You also have Fossick, and even you have Sumatra PDF as well. Okay, basically it's been mainly been used for runtime exploit setup. Like you're not gonna put like plain text for your exploit within a PDF. So you pretty much construct during runtime for your exploit to trigger. And then of course you're talking about shellcode obfuscation setup. Normally you generate shellcode on the fly to make to make your PDF obfuscated, I think. And of course, majority of the PDF that we saw implementation of the JavaScript is mainly for heap spray. But recently, if you notice that it's like a couple of deep spray stuff is also been implemented as well. And of course, the main reason is to make analysis. Well, one of the main reasons is to try to make analysis harder. Well, how it looks like? Pretty much, if you notice over here, you have var A. This is a very typical JavaScript operation. You have var A, var B, and then you have var C, blah blah blah, and then you have you combine all this stuff and you execute it. And then another typical JavaScript function that's been used is argument.curly. And another thing that's normally been used is ASCII conversion. Like you have 0x41 is basically representing 4A. And for example, within the PDF you have a dictionary called /filter, and /filter is going to retrieve some key value, which is a flag decode. And instead of representing as a flag decode, you can also spelling or using an ASCII convention. For example, you take a look at this sample over here. So it pretty much start with 50 ARE and so on and so forth. Okay. And of course, we see a usual suspect for encoder like base64, ROT13, and so on and so forth. And normally for JavaScript obfuscation, they try to make one-liner code because JavaScript always ends the code execution by the semicolon. So the new line really doesn't bother. So normally they try to screw up the code, the formatting of the code by implementing just one line of code. And then sometimes you also have some spaghetti code. If you take a look at the sample here, you pretty much notice this is just a declaration of function, and the last one is probably tried and catch loop, right? But this is pretty much a try loop. But isn't, oh, okay, sorry. Over here. So you should notice, so I can make it bigger. Oops. I don't think you guys can see it, right? Can you guys see it? But somehow rather over here is kind of the loop that you can see, loop for try and catch. But really this is not the execution path, because it started at early on before that. Like you notice here there is an if-else function, okay? So this is pretty much a very generic, JavaScript obfuscation. It's not really obfuscation. It's kind of like spaghetti. You combine multiple code and function within, And then sometimes they also come with a half pyramid. Sometimes, as you notice here, it's kind of like a running bunch of heap spray stuff. So sometimes even can make pyramid. Probably the guy is boring, so try to make it look like pyramid. And then dealing with the JavaScript obfuscation can be annoying. Normally, this is pretty much you always end up. It's always like, because there are many ways people can fool you with the JavaScript. Like I said previously, JavaScript obfuscation involved with creativity. So if the bad guy is much creative than the analyst, so you always end up like this way, fuck something, okay? But I believe with the help of tool, you will be probably more relaxed a little bit. So you kind of release, because there is a tool for you to help you to automate or make your analysis more easier. For example, if you're talking about, to run the JavaScript, you need to have some sort of emulator for that. Because you try to trace one, by your bare hand, well, I wish you good luck to manage to go through all the code. And for emulator, you have a Spider Monkey, Rhino, or even you have can try Google V8. And of course, like I mentioned earlier about the code spaghetti stuff, you can use a code beautifier, like a JS beautifier, which is pretty much been ported to almost IDE or code editor. And you can also implement some sort of a JavaScript dynamic instrumentation tool as well to see the obfuscation, to see the runtime of a JavaScript. Okay? But then, having said so, it's pretty much, if you take a look at the previous sample of the JavaScript, you pretty much can read all this stuff, right? But maybe in the future, it may come to within this function. This is valid JavaScript implementation, okay? And then may also come with the smiley characters for you guys. So this is kind of obfuscation that you can see within the JavaScript implementation in PDF. And there's a second normal obfuscation that we saw is about abusing the PDF syntax. For example, if you notice the /root over here, which is I mentioned earlier on, within the startup of the PDF, normally going to start with the /root. At the beginning of it, need to go to root. And this one is specified the object / the starting point of this PDF always going to refer to the object 21. It will be referred by the object 21. So any execution path will be start on the object 21. It's no longer about object 10 obj. Because the normal thing that we saw, the mistake that we've done, is when you start working with analysis on the PDF, you start by looking at the %PDF version, and you go with one by one of the PDF component. But really, you need to start from the /root. And another thing is about referring to another object. For example, you notice the var here. Okay, the variable var is pointing to the function called, not a function, is pointing to object called this.info.title, which is the kind of OO representation, which is this normally refer to the object itself, refer to the PDF itself, and .info is always referred to another component, like for example this one, /info, and /info is it's a reference to the object 5, so this is the object 5, and then this is your title. So your variable of root will be this string. Okay, that's pretty much obfuscation that we saw in the PDF. Okay, I talk about the syntax of the PDF and NF file, right? And normally, how you start parsing your PDF file? If you're building some PDF tools to analyze a PDF, which one you start for? You're looking at the percent PDF version, or you're looking for NF file? According to the Adobe reference, you somehow should start from the end file of the PDF. But the problem is, you choose to read from NF file, which one is going to be the first NF file? Because like I mentioned earlier, you can have multiple NF file within your single file of PDF. For example, this one. If you start from NF file, right? If you're passing your PDF file using NF file as a starting point, which NF file that you want to refer? You want to refer to this one, or you want to refer to this one? Well, this is pretty much legitimate declaration. If you open, it's not a malform PDF. Your reader, majority of reader, well, I have touched with the Nitro, Adobe, touched with the Foxic, and even events, they open nicely. This is not even a problem with this. So if you build a parser, which one you want you choose, okay? And then, for example, if you choose the last one, okay? If you choose the last one, okay? And then how about this? Okay, if you choose the last one on the NF file, and take a look at the object 12, okay? If you choose the last one, this one, so in this NF file, you have multiple object declaration for the object 12. For example, you have 1, you have 2 here. So which one is, if you start from here, which data now is representing by the NF file? We've been representing by the object 12. Because, for example, the first object 12 now here is have a data that say task first NF file. The second one is task NF file, second NF file. I will show you a demo about this later on. And then another one here. Okay, but the truth is, NF file is not even needed. It's not even needed. If there is no NF file, your PDF application or reader can somehow manage to render it properly. So the last one of the declaration, for example, on this one, if you notice from this one, the object 12, the last object 12 is always going to be the one that will be picked up by your PDF application. So like I said, this one declaration for object 12. So this, the last object 12, will always be executed. Okay? So this is the one. So the last one will always be being used by a PDF reader. So for example, the demo. So the first one, let me open with this. If you open this file, oh crap. It's freaking slow. For example, this one, this is your first NF file. But you can put a bunch of other things as well below of it. Like this is object 12. You end with another NF file. And this is interesting. You have here you have object 12. And inside the object 12, you have another NF file. And then this is pretty much another the data that belongs to object 12. You notice here the second NF file. And you have the third one NF file. So if you open this file, It's always slow when it comes to demo. Okay, so you just open end of file for the second one, right? Because the last one is always will be the one that will be chosen by the PDF reader. So this one, I open with this one again. This one, it don't even have the end of file, but if you open it with any PDF reader, everything is just fine. For example, this one, below this, that is no longer end of file, but you have like object 12 here, and you also have object 12 here. And then if you just open this, you can still get an end of file. So very tricky one to find where you can stop. When you're building the parser, it's very tricky where you want to find a starting point and try to parse for every single object within the PDF. For example, in future, I believe for the PDF have something like this. For example, the reference to the object that create loop. For example, you have the object 1 that have the dictionary for author, which is pointing to object 6 over here, and object 6 author have also pointing to the object 1. If you open it with any PDF application, it may stop. But if you're building your own parser, when are you going to stop your loop, right? So that would be interesting to see when we should stop. Okay. Then another thing is about abusing the PDF syntax is related to the Acrobat are specifically designed for the PDF engine, especially for the Adobe. A couple of JavaScript functions like get anode, sing anode scan, get page number. For example, get a word. Now, for example, get page and word. This one basically try to get a word on page specific, and get page and word to 1 is basically get the third word of page 1, for example. So and then you can select based on page as well. So this is pretty much normally been implemented with the obfuscation on the PDF. For example, this is one of the functions. You can see this one like this get page number, and this select page number something. Okay, so it's very difficult. It's not. I would say it's very difficult, but it's difficult to emulate all of the Acrobat JS engine to your own parser, because this kind of JavaScript code is not supported by default for like for public Acrobat PDF engine. Sorry, JavaScript engine like SpiderMonkey V8. It's not been designed for this. Okay. Another thing is, like I mentioned earlier, you can abuse incomplete syntax. For example, like object stream. For example, this is object 1. We start with a 1, 0, obj. So you pretty much expecting it need to be end with obj. But then if you don't have an obj, that's no problem. Your PDF application will just load it fine. But if you build your own parser, you need to know where to stop. All right. And for example, this is stream. You are expecting to have end stream, but if you don't have, it's also fine. And even funnier, you have stream, you have another stream, and you have end stream. You have end stream here. So which stream, which data that belong to this stream, for example, this one, or this one, or this one, or this one. Right? It's very tricky to analyze all of it. Okay, so another thing is, like I mentioned, the problem with this is difficult to emulate or to automate within the parser. Something like I mentioned earlier, emulating AcroJS code, finding stopping loop, and finding ending tag for like ends, obj, and stream. And of course, need to understand how the PDF reader application parser actually work. But then, are we building another PDF reader application? I think not, right? We are building the parser that to analyze the malicious PDF. I put it here. We organized a challenge for 100 project last year. So a couple of tricks being implemented over there. If you're interested to see the tricks, so try to get along with the challenge. And seems very difficult to automate this analysis, so manual tools are recommended. A manual tools is something like you don't really process the whole thing. You just somehow grab any object and then you just display the object. So you can manually trace the component that belongs to the object. For example, you can follow the PDF flow. You can manually inspect each object or each stream, so you know where it should end. And dealing with the AcroJet with still pain in the ass, I think. A couple of tools that you can play around with the PDF stream dumper, PDF examiner, PDF dissector, and file insect. Another thing that you can abuse within the PDF obfuscation is try to abusing the filter. The main category for here is I put PDF features. Obviously, one of the normal features in PDF is filter. Well, the main reason for filter is basically try to compress the size of PDF. So you normally use some encoding to compress it. So if you're using less known filter, for example, CCITF fax decode and DCTD decode, it's pretty much a highly chance for your malicious PDF not being detected. But somehow in general filter, it's normally you have flag decode, ASCII hex decode, and a couple bunch of ASCII like ASCII85, JBIG2 decode. And this is also interesting as well, because if you see at the filter dictionary, it can accept a couple of parameters. So if you want to make your filter have some strict parameter, so that if you're using like, if you try to incompress without passing this parameter, your decompressing will be failed. You can implement it within the parameter called decode palm. For example, this one, this code implement CCITF fax decode. It's normally for image, but really it doesn't really matter. It's not necessarily image. You can put whatever you want, as long as it's within the format of the CCITF fax decode. And then you can also abuse the filter by implementing some multiple layer of filter. For example, you have combining of ASCII85 decode and with the LZWD decode. So you just combine between it. Well, there is no limit for you to play around with it. So you can add a multiple filter on this one. For example, this one implement flag decode and going to do ASCII hex decode later on. And you can also do some abbreviation, especially on this one, like A55 is belong to ASCII85 decode, LZW is belong to this one, LW decode. So this kind of abbreviation somehow, if you don't put it within your parser, it would be difficult for you to decompress all these filter. And another interesting part of this, try to abuse encrypt. Encrypt is something that when you have PDF, secretive PDF, you normally try to put a password protected on this PDF, right? And if you put that as, on your PDF, so pretty much your stream and your string gonna be encrypted. Okay, so in Adobe, they're implementing RC4 and AES algorithm. So for example, on this one, this is not, when I mentioned about encrypt, this is not really about protecting the document itself, it's rather protecting the stream. So, for example, /root have dictionary encrypt, so it will point to the object 76 over here. So if you took the object 76 here, it has declaration is going to be encrypted with the AES encryption, and then okay, so with this one, if you ask like a password or something, like normally when you open PDF, it will trigger like keep a password for that. Well, we have a sample like if depending on the /root that where it start, you have where you busy keeping the password is already can drop some exploit that trigger the exploitation already. So. And then, of course, somehow it depends on the event, like auth event. Like, for example, you have .open. So it will trigger when you open the PDF. Okay. So, but then if your slash root have a pointer that points to different objects that have exploit on it, so it will trigger that first, and then we ask the action from this event. Well, it's pretty much difficult to analyze it because simply the fact that you can dump the string because you need to break the encryption out of it, right? So there is no plain text. So for example, a demo, a quick one. All right, for example, I try to open this with a file inside first to show that this file is that have encryption. Like I mentioned, please go to your slash root first. A flash root normally have within the trailer. So here you have like definition for encrypt, which is points to the object 29. But your slash root here have the object pointing to object 10 first, okay? And then this encrypt have pointing to object 29, I think. 29. So if you go to the object 29, so this is pretty much the implementation of our C algorithm for the encryption. Okay, so we have some like stream over here. For example, take a look here. This stream have implementing some sort of flag decode algorithm, flag decode filter. So pretty much if you try to decode this one using a zlib encoding, it should work. For example, if you select this one, so you just select, and then you right-click, and then you can go to decode and try to inflate. Of course, you cannot do inflate, right? Because it's already been encrypted. And then if you run this using a PDF application, the exploit might trigger, but then yet you couldn't find what kind of exploit I used for this one, right? It will take a while for exploit to work because I'm running some sort of heap spray on top of it, so it took a while. I think we go to this screen after a couple of like all right. So and then the fourth one that we normally see within the PDF application is try to use on media reach on the PDF reader, because the fact that they have many media type that they support, so pretty much you can embed a couple of media, for example, AIF, .mov, .mp3, and even now that SWF. So if you attach any exploit within the PDF file against this media player, well, you normally win, because people not really suspicious to click on PDF rather than clicking on the MP3 and .mov that come over your email or something. Okay, and normally for the PDF is used against the flash 0-day. So you have normal PDF, good-looking PDF. It's not malformed, but you have bugs on Adobe and the Flash. You get on as well, right? How does it look like within your PDF structures? For example, you start with a slash root again. You check slash root is pointing to object 31, and then object 31 have the page pointing to page object 1. So you go to the object 1 here, and then you have page. And page somehow have a reference on the object 12. You go to the object 12, and object 12 is somehow have flash file on top of it. Okay. If you see SWF is basically CWS basically compressed file, and then this is another one called FWS is uncompressed file. PDF is just pretty much the main transporter for this one. You need to extract the flash file to check what is the exploit, what kind of shellcode inside it. Okay, so tools normally you can use like PDF stream dumper and plus the PDF examiner for this one. And then of course you can do a flash analysis later on to trace what's really happened when you open the PDF. As we know, the PDF have engine for the flash, right? So for the flash analysis, pretty much very ideal for us to decompiling flash bytecode, which is normally try to from the AS3 or to AS2 to AS2 or AS3 code. Idea, but so far I saw it's only 2 software that do a proper decompiling on this one, but it's a commercial, so you cannot somehow integrate this kind of tool within your parser. So Shooting Flash decompiler have decompiler for this one, and if you look for the PDF stream dumper, they have another proprietary tool as well called AS3 software on this one. So this is pretty much the decompiling code look like on the AS3. It's pretty much AS3 code here. And if you cannot do a decompiling, you can always do some bytecode analysis here. So for example, this one is pretty much try to construct the knob slack for the shellcode. You can see over here that's push some stuff, push integer, and this is a couple of loop over here to assign the array. And this is another pushing some ROP gadget on top of the shellcode. And then pretty much here, you can also put some shellcode and try to translate it and try to do encrypted. So when it comes within the PDF, you just have a properly not say encrypted, properly obfuscated flash file within your normal PDF. Let's see for this one. I think this is pretty much when you open the PDF. The demo just now showed that when you open the PDF, it just gives you a calculator, and then you crash. But then again, we don't even know what is the exploit that used for this one. All right. So this is pretty much, this is not the main focus of this presentation. I just show here basically how you can do analysis on the flash exploit that embedded within the PDF. Okay. And then, so this is a challenge and issue I would like to share with you guys, and hope there is a probably answer for a couple of these challenge. I would say building a complete PDF parser is a task. It's a very tough task. Having a lexical analyzer is one thing, but the not so standard or parsing object is another. Okay, and embedded component also need attention, like font. How many exploit that are leveraged on font that been used? Recently, you know, on iOS, jailbreak Me 3 is also starting from the font as well, right? And of course, media, flash, audio, and stuff is also main problem as well now to address within the PDF parser or PDF analyzer. And of course, it's try to fully compatible JavaScript to emulate this is very painful, especially that has a specific on acro.js function. And inspection of the whole part of potential execution within the PDF reader application context is hard. For example, if you try to analyze outside of context of PDF reader context, it would be difficult to find out the flow of it. For example, you have app version, viewer version 9, you have a different execution. So you need to mimic all this environment within your analyzer. And well, even though they have a challenge and issue, I think a lot of effort have been done to translate within the tools. Like you have PDF Miner, you have origami that can be used within the library on Python on Ruby, and of course you have a famous digestive stuff, and then PDF Stream Dumper, PDF Dissector, which is a commercial, I think that one, and PowerView. Yeah, even and then there's also a couple of online PDF analyzers as well. The one that we built is called Galus. Then I think the Web Power Fame, JS Unpack, and PDF Examiner. And the last one is also built by our friend, our previous presenter about PDF analyzer called APT User. So still, all these applications that have been built, it's not fully 100% are comparable with how the PDF reader application works. So it's very tricky. And then conclusion that I can draw from my presentation for today is many obfuscation methods to hide a malicious PDF. Like you can do over JavaScript, you can do a PDF syntax, you can abuse some features. And for the features, it also leads to many problems on this one. Like you have /filter, which gives you some sort of independent to do some encoding. And you also have something like /launch to launch whatever command that you want. Well, it's nice, it's convenient, but it also can lead to a different problem as well. And you also have like /encrypt, which is I just showed a demo. And again, encryption is a major stumble block. Good to protect your secret data. And then it's also so does for the 0-day protection as well. You can protect a 0-day within this encrypt function. More complex technique on exploitation will make analysis more difficult, I think. For example, Comex PDF from iOS to lead to the kernel exploitation. Of course, there is a kernel bug as well on this, right? And of course, I don't know, big malicious PDF embedded file scanner or detector engine within the reader application itself is a good idea, because I believe it would be good because you have a context within the PDF reader, okay? But for some reason, I think it's also a bad idea. If you add another engine on top of it, you add a complexity of code base, which is also meant to do bugs within the engine itself. It would be embarrassed to have the code to do a scanner for malicious stuff. It's also vulnerable for the bugs, all right? So pretty much that's the conclusion. And if you're interested in this PDF weirdness, you can read all these PDF reference from Adobe, this one. And of course, you can also read, well, they have a different reference on both of these. This one is specifically for JavaScript scripting engine. So you can read on this as well. And of course, a couple of researchers have been working on this, like Sebastian Voss have been working on this, and also Julia Wolf has also been working on this as well. And then, yeah, thanks for all these people that have been working on this field. And then I think that is all from my presentation for today.